Okay, I wanted to just do a couple of examples and record what I was doing. So this is we didn't get time to really work through any of the examples in class. So this is example, the second example that we have on the lecture note. So again, the switch flips at time t equals 0. So before time t equals 0, this switch is open, and essentially the capacitor can charge up. When the switch is closed at time t equal to 0, you see this voltage here is then going to, or the voltage on the capacitor is then going to try to drain through this other resistor. So before time t equal to 0, we have and what we need to do, the voltage across the capacitor, V across the capacitor, is going to be the final voltage plus the initial voltage minus the final voltage, e to the minus t over tau. So what we need to do is we need to find the final voltage, the initial voltage, and tau. Okay, so to find the initial voltage, what we're going to do is look at time t, t before 0, and assume that the circuit, everything is charged up. So or it has been there for a long time. So remember, current can't really pass through this capacitor. So what happens is this voltage just, current flows onto the capacitor until it charges up to 72 volts, and then no more current can flow, right? You'll have 72 volts here, and the current will be 0. So the initial current, or the initial voltage, VI, is going to be 72 volts. So here we could, in our notation, VI is going to be 72 volts. Now if you look after the switch, so when the switch is closed, now we have this line in here. And again, we might ask ourselves, what happens when the switch is closed? So in this particular case, again, the capacitor, basically once the capacitor is, discharged, it will be, the voltage here. So what's going to happen is that the voltage is going to discharge until basically this voltage is equal to that voltage, and no more current can flow in or out of the capacitor. So you could think of it as basically, in that case, this is like an open, or an open circuit. So you would have 72 volts that gets split across an 8 ohm and 8 ohm resistor. So this is a voltage divider where we've got equal resistors. So 72 splits in half. So when this voltage is equal to 36 volts, you see no current can flow in or out of the capacitor. So the V final here is going to be 36. VF is equal to 36 volts. Okay, so we have the initial voltage, final voltage, and then now we need to find the Thevenin resistance. If we were to look at the terminals of the capacitor, we want to find the Thevenin resistance looking into this circuit. So one way we can do it, we could do it with source transformations, where we take the voltage source in the capacitor, turn it into a current source in the capacitor, or current source in a resistor, combine the resistors in parallel, and then convert back to a voltage source and a resistor, and we'll see a 4 ohm resistance for the Thevenin resistance. Another way we can think about it is to set this voltage source to 0. So this is like a wire. And now looking in, we have an 8 ohm resistor in parallel with an 8 ohm resistor. So that's going to give us 4 ohms. So again, our Thevenin resistance looking in is going to be 4. So the time constant tau is going to be, 4 times the value of the capacitor, or in this case, 400 microseconds. So the voltage across the capacitor, if we say VF plus VI minus VF, e to the minus t over tau, VF is going to be 36, and then VI is 72 minus 36, that gives us 36, and then minus t over tau, time, and the units of this whole thing is in units of volts. All right, so that's example 2. Here's example 3. In this particular case, again, the switch closes at time t equal to 0. So before time t equals 0, we assume that the circuit's been doing its thing for a long period of time. And so basically, after a long period of time, this inductor essentially acts like a wire because there's no change in the current. So what's been happening is basically, we have enough current. The current flowing here is going to be simply 72 volts divided by 8 ohms. So the initial current is going to be 72 divided by 8, or 9 amps. So I guess what are we trying to find? Okay, if we're trying to find IL, then IL is going to be 9 amps. And basically, here we could think of this as a wire when t is greater than 0. Now, after the switch has been closed and we let the circuit settle out, again, we're going to think of, the current here won't be changing. So as time goes to infinity, we could think of that inductor as just being a wire. And now you have 72 volts that is sending current, through an equivalent resistance of 4 ohms. So the final current is going to be 9 divided by 4,